we're working with quadratics in vertex form for this section. So remember, the vertex form is of the form y is equal to ax minus h squared plus k. And this gives us a whole bunch of things that we can do. We can graph it, we can tell whether it's opening up or down, we can say whether it's a transformation left or right. We could pretty much do anything with this, all right? So by the end of this lesson, we're going to have the ability to do word problems with these basic questions. This is going to be crazy. And some of these word problems are going to be things that you've never seen before, but we have the skills to do it. So what we're going to do is we're going to take a look at question number 1A, which asks us to describe what's going on with this equation here. Remember, our basic equation is y is equal to ax minus h squared plus k. Now let me just quickly fix that up there. That didn't come out nice. So we have our minus h squared plus k. So when we take a look at this basic equation, y is equal to 2x minus 4 squared minus 3, we're going to have to read it from left to right. So I'm going to read this part in red, in black. I'm going to read this part in red, and I'm going to figure out what this part means in blue. So let's do those 3 stages from left to right. So for number 1, the description of what's happening is you'd notice that a is bigger than 0. So that means this is a vertical stretch. And it's a stretch of factor 2. Now, as for the stuff that's underlined in red, we have to use the concept of what I used to call opposite world years ago when I first started doing this. Made my life easy, too. Whatever's inside that bracket is always read as the opposite of what it means. So if you think about it, it's telling me that my axis of symmetry is x equals 4. That also, if you think about it, gives us information on the vertex. And the vertex, I'm going to call it V. And so because it's minus 4 here, it's positive 4 here. Now, you know from our practice that if it's minus 4, it means that minus 4 means this parabola moves right 4 units. And the stuff that's in the blue, I'm going to say, because it's on the outside, we take it for what it is. It's minus 3. So this means our parabola moves down 3 units. And that's all we need. So that means for this parabola, in our vertex, basically we got from the axis of symmetry, from the concept of moving right 4 units, we got a 4 for the first part of the vertex. And as for the second part of the vertex, in blue, the moving down 3 units gives us the second half of the vertex, which is the y value of the vertex. So now that I know that my vertex is 4, -3 because it's moved down 3 units, what we're going to do is we're going to take that information and put it onto our graph, because remember, our problem asked us to actually take a moment and graph this thing. So based on what we know, the vertex had that original equation tells us that there's a vertical stretch factor 2. It moves right 4 units and it goes down 3 units. So once we go and plot this thing, we're going to have something kind of nice. So it's 4 and down 3, so there's our first point. And now, for graphing, remember we always had to get the vertex for our graph. And remember, anytime you draw up a graph, you got to give me the equation of the graph. And the equation is going to be y is equal to 2x minus 4 squared minus 3. Okay? Alright, so let's just move this down so we get the minus 3 in there. And we're good to go. Minus 3. So now, based on our graph, there's our first point, 4, -3 on our chart here. Okay? So now that I have 4, -3 showing up on here, right, we have to find the steps. So remember, when we dealt with the steps of every parabola, the basic parabola, y equals x squared, starts with 1, 3, and 5 for its steps. Then, when we talk about the new steps for a new graph, we have to go and take a look at what number is subbing in for a. And in our equation up there, in our equation that we have right here, we have 2 being our a value. So now we have to take the number 2 and times it by everything that's to the left of this thing, where it says 1, 3, and 5 for its steps. So now 1, 3, and 5 become 2, 6, and 10. So that means we're going to have to go over to our vertex here, right? And then we're going to have to go over 1. And instead of going up 1, what we did before, now we have to go up 2 to this point here. So let's draw that in. Now, from this point, we're going to use the 6 from our steps here. So we're going to have to go over 1 and then go up 6 spots. And that gets us right here where the number 5 is. So it's 6, 5. So we'll draw that in. And now you remember that the vertical line that goes through the vertex is our axis of symmetry, the AOS, right? And the AOS in this case is 4. And now because I have an AOS, I can take that AOS and mirror my information to the other side. So if I have a 1 here, I can map it over here. If I have a point here to the right side of this thing, I can go 2 spots over and mirror it. And now all we have to do is take a moment and graph. And once we've connected all the dots, that's what we get for our graph. Okay? So there's only a few more things to do for our lesson, so let's find out what we have to do. All right, so it says describe the steps of this graph. And then what can y take and what is the max and minimum. So the steps to find the graph, well, the steps to find the graph are the following. 1, you find the vertex. 2, you find the steps. 3, and use them for our step method. Now, the last thing that I need you to do, it says, so now it's asking what values can y take. So if I look at this graph and I move and I follow the graph up, right? Our lowest point is y being -3. But because it's opening up, all the values of y are greater than or equal to -3. Now, these are the values that y can take because all of the points for the graph are above it. Now, that's the first part. The second part, let's see what else it asks. The second part says, what is the max or min? If I look at this graph, I would say my minimum